This is a demonstration of the AI-DAPT model observability and adaptive AI. These complementary services help monitor machine learning models after deployment and support adaptation when performance changes. Model observability tracks model behavior, performance, and data drift, while adaptive AI uses these insights to recommend or trigger adaptation actions based on user-defined rules. Together, they enable monitored, adaptive AI workflows while keeping humans in control. Let's see them in action.
Welcome to the Model Observability and Adaptive AI walkthrough. These two services have been designed to work together in order to create a continuous loop to monitor and update models exhibiting performance drift. Let's go and configure our first project. We can see the available models currently in the platform that do not have Model Observability project configured just yet. And we will start by setting our pipeline. First, we need to define what is the problem type. We have regression, binary and multi-class classification. Then we should choose the monitored pipeline and its dataset. What is this essentially? This is the data that we want to observe how our model is behaving at. And lastly, we have the reference pipeline and its associated dataset, which we're going to use as a baseline in order to create all the necessary comparisons. So this is usually the test set coming from the inference phase post-model training, and it should include the training features, model predictions, and the ground truth labels. One important requirement here is that those datasets should share the exact same schema. Now, the data aggregation needs to be specified, either grouping our data by a specific period or a specific chunk size. So let's select, for example, daily periodicity, and also select our timestamp column. In cases where chunk size is selected, then the timestamp column is no longer a requirement. The third step involves column mapping and choosing the metrics we wish to monitor our model against. But first, we need to define our columns. We need to define which column contains the ground truth labels, which one the predictions, and which one the prediction probabilities in cases of classification problems. Then we select one or more metrics that we wish to see. And optionally, we have the ability to select custom threshold, either standard deviation multipliers or constant numbers. But if left blank, then the system can automatically configure the threshold based on the reference dataset. Just as a quick note, this would be the view for a regression model where no prediction probability is required, and the monitor are correct for this type of problem. Moving on, the next two steps are optional. The first one is univalid data drifts, where the user can select the features that they want to analyze, and each feature here is going to be analyzed for potential drift individually. So ideally here, we would select the features that the model was trained with. There is also the ability to force numerical or categorical types, but if left blank, the system automatically finds the most appropriate data type for each of the columns, and then we should define the metrics that we want our features to be evaluated with. The same rule applies for the thresholds as well. They can be either customly defined or auto-configured by the system. Next, we have the multivariate data drift configuration, where the goal here is to analyze how features behave all together as a collective set. So we should select our features here and click on Next. So to finish up, we review our configuration and see that everything is as we wished, and click on Finalize to complete the pipeline. The results are now in the pipeline's dedicated dashboard, which we will go over now. As you can see, the dashboard displays some KPIs on top, involving the chunks that have been monitored and alerts that have been created. We have a full breakdown for each of the chunks. We can also show the ones that have not exhibited any kind of alert, and we can, for example, filter by a specific metric. Moving on, here we can see how our model is behaving through time. We can also filter by the desired metric. On the left side, as a quick overview on the green space, this is how our model is behaving on the reference data. This is the baseline performance, essentially. And as you can see, we have both the estimated and the realized. Where we realized, we mean that ground truth labels are available, hence this is the actual performance. Whilst with the estimated, the ground truth labels are not yet available in the monitored dataset. Hence, the system estimates if there would be a potential drift. Moving on, this is the data drift section, where we have the breakdown for the chunks, but this time we actually analyze each of the selected features. We can also filter by specific method, and we can see the status of the feature in each of the chunks and understand what is happening. Last, we have the data drift through time charts. The first one is the univariate data drift. We can select up to 3 features here, and we can also filter by a specific metric and see what is happening through time. And last but not least, we have the multivariate chart as well, where we can see how our features are behaving over time as a collective set. And now let's move on to the adaptive AI service, where here actions can be set based on those observability alerts that we just saw. First, we have the model view. This is like a model catalog and shows every accessible model currently available in the platform. We can see if an observability pipeline is set up and running and what its actual outcome was, and if any adaptiveness rules have been configured for that specific model. There is also an alerts view where we can see every alert that has been triggered in the past. Let's go and configure rules for the model we just created, an observability pipeline. First, we need to define some conditions. We have 2 types of conditions. The first one is the temporal, where temporal conditions include when the preferred action should take place based on time. Here we select, for example, an exact timestamp. And we also have the metrics based. Those trigger the preferred action the moment a specific metric threshold is violated, and this ties back the respective model observability pipeline we just created. When a condition is met, we need to take some action. Currently, there are 3 types of actions we can select from: A, retrain, B, rebuild, and C, replace. For this demonstration, we're going to choose the replace action, where this essentially provides the ability to compare alternative models trained on the same problem and evaluate whether the current model selected should be swapped out. So here we would have a list of the models with defined model observability pipelines. We should select the appropriate ones that have a similar model observability pipeline to our model, and once done, close the rule configuration page. Moving on to the monitor and adapt section, we can have a look if some of our conditions have met, if some metrics have been violated, etc. For example, we can see that we have an alert for precision, as we also show in the model observability dashboard, and we can witness the alert history, where we have 1 temporal condition and 1 matrix base. So therefore, we have to decide what we're going to do. For the replace option, we can see the alternative models available and check how they are behaving compared to our model. We can also swap the round, and we see actually that the alternative model 3 would perform better in this case. So we choose the action replace, click on apply, confirm, and as you can see, the status has changed, and our action has been monitored and applied, concluding the whole monitoring flow.